Ho, 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 ho. Day 3 of the Advent of Code. Yesterday, an elf tried to trick me with a scam that we practically invented in Italy. Today, we are stuck in a gondola. Are we in Venice? Well, this year, the Advent of Code feels right at home for me. So let's go and solve day 3. Okay, part 1, what do we need to do? So we need to find all of the numbers that are adjacent to a symbol that is not a dot. So for example, this 172 is not valid, but these 823 and 835 are, because they are adjacent diagonally to the star. And also this 712, for example, is valid because of this symbol here. So we find all of those numbers, we sum them up together, we get the answer. Pretty simple. So how do we do it? We get the input file into this string, see the video from yesterday on how embed works. Then we have a coordinate struct which contains x and y as integers, and a method on the struct that allows us to get back all of the 8 neighbors and the cell, the coordinate itself. How does the solution work? So we define a function match symbol that matches all of the symbols that are not dots. And then another function that keeps summing the numbers that is given to a sum variable. And we pass those two functions to the run function. Now, all the magic happens into run. And this works as follows. So we go through the matrix, and whenever we match a symbol according to the match symbol function, so for this part 1, we match any symbol that is not a dot, we add it to a set, which we have here. Then we pretty much go through the matrix again with these nested for loops. And what we do is that on each line, whenever we find a digit, if it's the first digit we encounter, we start parsing a number, which we call part, because the Advent of Code calls it that way. And we also know at what x in the line that number starts. Then we go to the next character, and if it's again a digit, we add it to our number until we get to a point where it's not a digit anymore. So we get into this branch here where we mark the end of our number, and then we check if it's a valid number, which means this number is adjacent to a symbol. If it is, we call the callback, which will add to the sum. And yeah, well, we need to repeat this check twice because we could be still parsing at the end of the line. So here we need to check if it's something that if that's the case, pretty much. Cool. This valid function, as I said, it goes through all of the neighbors of our number, and if any neighbor is a symbol according to the symbol set, then we return true, which means we need to count it into our sum. And then again, since we call this run inside of part 1, we will end up with the sum in this variable, which we define here, and we can just return it. Okay, part 2. So here we do something slightly different. In part 1, we were taking all of the numbers that were adjacent to a symbol that was not a dot. In part 2, we need to find all of the pairs of numbers that have a star in common. So for example, we have this pair here, which is adjacent to a star. Okay, so how does it work? We this time define a match symbol function that just finds stars. And then we have a map where the key is a coordinate and the value is a slice of integers. where the coordinate is a star symbol, and the slice is all of the numbers that are adjacent to the symbol, to the star, that is present at those coordinates. So when we run our run function, we end up with a dictionary which we can enumerate, and whenever we find a star symbol that has two numbers associated with it, we can combine them the way the Advent of Code asks us to do and get our result. And with the help of tabs, nested for loops, and first-class functions, we fixed our gondola. If only life was always that simple. Let me know what you would have done differently in the comments, and I'll see you in the next one.